Okay, so our first topic is matrices, right? So what is this matrix? What is this matrix means and what is its application? So matrix is a rectangular array of elements or rectangular arrangement of elements or rectangular arrangement of numbers, right? So this is rectangular arrangement means what you write here: A11, A12, A13, like this. A21, A22, A23. I wrote here some numbers I wrote here. This is rectangular arrangement or rectangular array of elements. So this is called matrix. So matrices is plural and matrix is singular. Matrix is singular and matrices is plural of matrix. So matrices, you understand, matrix means rectangular array of elements. So here you have here this is horizontal. This is horizontal line, right? Horizontal, two horizontal rows are there and three vertical. So horizontal is called rows. Row one, this is row, right? And vertical, this is white vertical lines. This is called columns. Column, right? Columns. So here two rows are there and three columns are there. Whenever we say matrix, immediately we should tell it's order. This is called order of matrix. Okay, order of matrix. So here this matrix has two rows and three columns. Therefore, order of matrix is 2 by 3. So now generally order of matrix we represent with M cross N. M by N. This is dimension, like dimension. M by N matrix. M by N matrix means what? M by N matrix means M columns are there, N rows are there. So M by N matrix will write general matrix of M by N. So here we write A11. That means what? First row, first column element. This is A12. This is very important to write this. A first row, first column. First row, second column. This is in first row, second column, right? This is first row and this is second column. So first you should be familiar with rows and columns. A13, A14, so on up to A1n. That means what? First row, nth column. This is first row, first column. This is first row, second column. See, this is second column. Column is 2. Second column. This is first row, third column. This is first row, fourth column. First column, second column, third column, fourth column, nth column. Right. Second row, first column. Second row, second column. Second row, third column. Second row, fourth column. Like that. This is second row, nth column. Now so on. The third row, first column, fourth row. And now here we have M rows. So therefore, last row is mth. Mth row, first column. Mth row, second column. Mth row, third column. Mth row, fourth column. And so on up to mth row, nth column. So therefore, this is M by N. Whenever we write matrix, we have to write its column. Its order. We should write its order. So here we have two rows and two rows. This is first row, this is second row. Three columns, 1, 2, 3, like that. So two rows, three columns. We wrote here order 2 by 3 matrix. And here, how do we write matrix? We write matrix in, how do we represent matrix? How do we write matrix? We write matrix in two ways. Okay, two ways we can write matrix, two ways, right? So what are the two ways? We'll see what are the two ways. One way is we write in round brackets, parentheses, round brackets. See, A11, A12, A13, A21, A22, A23. Like this. This is one way. And another way. And we represent matrices with capital letters, matrix A. And then, or another way we write is matrix A. We can write like this in square brackets. That is, I wrote A11, A12, A13, and A21, A22, A23. Right? Like this we write. This is square brackets. Okay, and we represent with capital letters. And in matrix, whenever we write matrix, we write small letters only we write. For example, we want to write another matrix. I am writing this general matrix. So how do we write? A, B, C, D, E, F. Like this. Now here we have 2 rows and 3 columns. That means how many elements we have? 6 elements we have. 6 elements. Okay, 6 elements we have in this matrix. And sometimes students make this mistake. So let's say I have tried this matrix A. Let's say I have tried this matrix A. So this matrix, I am just calling some other name. This matrix I am calling some matrix B. So let's say I have tried matrix B. If I have to write matrix B, how the students write is like this. A, B, C, D, E, F. Like this they write. If you write like this is wrong. So you have to leave gap between. Like this, you have to leave gap and properly you should write. So this is representation of the matrix. And see, what is matrix? A rectangular arrangement of elements. And here, let's say we have, now let's see. So now what we saw is, what is matrix and how do we represent? We represent matrix with capital letters. And how do we write matrix? We can write matrix in either round brackets or square brackets, right? What is the order of the matrix? Whenever we write matrix, immediately we should write its order. That is 2 rows and 3 columns are there. That is the order of the matrix. So then we see next types of matrices. What are the types of matrices? Types of matrices. Types of matrices. What are the types of matrices? So first we'll see rectangular matrix. Rectangular matrix. What is this rectangular matrix? Rectangular matrix means here rows are number of rows. Number of rows not equal to number of columns. That is, number of rows are not equal to number of columns. So that means here 2 by 3 matrix is rectangular matrix. So for example, simple 1 by 3 or 2 by 3 or 4 by 3. We have only 3 by 3. Okay. We have maximum order of the matrix that we deal with is 3 by 3. Only 3 by 3 matrix is what we deal with. Okay, 4 by 3 and all is not there, but just for the sake of writing, we are writing. So that is rectangular matrix. So in this rectangular matrix, again, you have rectangular matrix means what? Simple. Number of rows is not equal to number of columns. I give example. And here first, here row matrix. So row matrix. What is row matrix? Only one row.
3 into 3 will not be rectangular matrix, no?
Yes, this is not rectangular matrix. That's true. That's true. We deal with the maximum, we deal with this 3 by 3 matrix. So here 4 by 3, just we don't in application, we don't have 4 by 3, just for the sake of example, I gave this example. Okay. Now we see in rectangular matrix, again we have a row matrix. Row matrix is not only one row. Only one row. Okay. And any number of columns. Any number of columns. Any number of columns. Only one row and any number of columns. Right? So this row matrix can be rectangular matrix or square matrix also. So here, rectangular matrix we discussed. And what is square matrix? Rectangular matrix means number of rows not equal to number of columns. Square matrix means what? Number of rows equal to number of columns. Number of rows equal to number of columns. Okay, here simply we can say m is not equal to n. And if m equal to n, okay, we'll write here. Okay, square matrix. Square matrix. Okay, we'll discuss square matrix. What is a square matrix? M equal to n. Number of rows equal to number of columns. Here, row matrix, only one row and any number of columns. Row matrix means. That means what? 1 by 2, 1 by 1 also, 1 by 3 also, 1 by 4 also, like that. So on. So generally, how do we write this matrix? This matrix we write like this. Why? How? A11, A12, A13, so on up to A1n. So this is only one row and n columns, 1 by n matrix. So this is row matrix. The next, yes, this is row matrix and the next column matrix. Okay, column matrix. So you must have understood now what is column matrix. Column matrix means what? Only one column. If at all you have to say, yeah, M, okay, M can be anything. M belongs to any natural number and N belongs, N equal to 1. And just N equal to 1. Okay, that is what is column matrix. So for example, here you can see this is column matrix 1, 2, 3. This is just column matrix, 3 rows and 1 column. Okay, or general what you can write? General what you can write is like this. Generally you can write like this. Right, A11, A21, so on up to AM1. That means what? M rows are there and 1 column is there. Okay, if you write like this, then you will be familiar. Okay, right? So this is column matrix. Right. So then we will go to next type of matrix. That is in square matrix. Square matrix we saw, right? This is square matrix. We see in square matrix some types are there in square matrix. So what is that? First is scalar matrix. Scalar matrix. What is this scalar matrix? Scalar matrix is scalar matrix means diagonal. Okay, first we will see diagonal matrix. We will see. Before that, diagonal matrix is diagonal matrix. Diagonal matrix. What is this diagonal matrix? So non-diagonal, diagonal matrix means non-diagonal elements. Non-diagonal elements are zeros. And diagonal elements can be, and diagonal elements can be any real numbers. Any real numbers. Okay. So this is what is non. So first of all, we'll see what is diagonal element. So in square matrix, this diagonal is there only in square matrix. Now let's take for the sake of easiness, we take 3 by 3 matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. Now this is called principal diagonal. And okay, this is principal diagonal. This is principal diagonal. Principal diagonal. Right? And here A11, A12, A13 are called diagonal elements. Diagonal elements. Okay. So now here diagonal matrix means non-diagonal elements are zeros. Then what about diagonal elements? They can be any elements. Okay. So for example, diagonal matrix means like this. 1, 0.
I have a small doubt.
Yeah.
So diagonal elements are A11, A12, A13. Shouldn't it be A11, A22, A33?
Exactly. Sorry. Yes, that's true. That's true. Yeah. 0, 2, 0 and 0, 0, 3. All right. Okay. Is that okay? So that
Yes,
is diagonal. So many times students get confused. For example, if I write like this, 0, 0, 0, 0, 2, 0, 0, 0, 0. This is also diagonal matrix. This is also diagonal matrix because we have to see non-diagonal elements are zeros. Non-diagonal elements are zeros. Diagonal elements can be any real number, including 0. That you should not get confused. Now, scalar matrix. Scalar matrix means what? This is scalar matrix is a square matrix. This is a square matrix. Square matrix. A square matrix in which square matrix in which diagonal elements are equal. Diagonal elements are equal and non-diagonal elements are zeros. Non-diagonal elements are zeros. Non-diagonal elements are zeros. Okay? I think you are clear. Non-diagonal. That means what? Diagonal matrix, square matrix. Another way we can say is this square scalar matrix. Another way, a scalar matrix. Another way we can say is this is diagonal matrix. Diagonal matrix only. This is scalar matrix is diagonal matrix in which diagonal elements are equal. Diagonal elements are equal. For example, 1 0 0 0 1 0 0 0 1. This is what is scalar matrix. This is scalar matrix, but this if I write 4 also, whatever, diagonal elements are all equal, non-diagonal elements are zeros. That is what is scalar matrix. So write 6 scalar matrix is over. And the next unit matrix. Unit matrix. What is this unit matrix?
A matrix with a single element.
No. Unit matrix. Single element, how do you know? You learned that way or what?
No, sir, I am asking because it's like unit, maybe it's like one.
Okay. Okay. So this is like this. 1 0.
Sir, I have a small doubt.
Yes, tell me.
Sir, the diagonal and scalar matrix are only possible if it's a square matrix, right?
Exactly. This is square matrix, scalar matrix.
Yes, sir.
Scalar
Got it.
square matrix. Whenever
Yes, sir.
we speak about diagonal, that is possible only in square matrix. Okay. Unit.
Yes, sir.
Unit matrix means this. Unit matrix means this is a scalar matrix in which all the diagonal elements are equal to 1. Okay. Right. A square matrix. So I'll write that scalar matrix. I'll write scalar matrix. Scalar matrix. Scalar matrix in which diagonal elements are all ones. Elements are equal to 1. This is what is unit matrix. This is you can call or multiplicative. This you know what is this? Another way. Identity matrix. Identity. Multiplicative identity matrix. You can also call multiplicative identity matrix. This is multiplicative identity also, or unit matrix also you can say. So the next one is zero matrix, right? Zero matrix means what? What is zero matrix? All the elements are zeros. All the elements are simply zeros. Okay, all the elements are zeros. So for example, this is zero matrix. This is also zero matrix. Okay, 1 by 2. This is also zero matrix. 2 by 2. Like that. Zero matrix means what? It can be square or rectangle also. Zero matrix means it can be square or rectangle. So this is diagonal matrix. This is scalar matrix. This is unit matrix or This is multiplicative identity also, you can call that one. Okay, so then if you see, this is diagonal, this is scalar matrix is diagonal matrix. Okay, scalar matrix is diagonal matrix. Okay, and here, this one if you see, this is square matrix. This is square matrix, diagonal matrix, scalar matrix, but it's not unit matrix or multiplicative identity matrix. Okay. Right. So the next triangular matrix. What is this triangular matrix? Triangular matrix means what? Here, triangular matrix means what? Upper triangular matrix and lower. Two types are there. Here we have two types. Two types. One is upper triangular matrix. Upper triangular matrix. And another is lower triangular matrix. Upper triangular matrix and lower triangular matrix. So upper triangular matrix means what? All the elements below diagonal are zeros. All the elements below diagonal are zeros. Simple. If I write the example, then immediately you will catch, then explanation will be easy. So this is 1, 0, 0. 2, 3, 0. Okay. 4, 5, 6. This is what is lower triangular matrix. Lower triangular matrix. This is what. And here that means what? This is principal diagonal, and all the elements above the principal diagonal are zeros. Okay, below the principal diagonal can be anything that you understand. Okay, all the elements above principal diagonal are zeros. Okay, that means triangle is formed here. That's why this is lower triangular matrix. So then next, if I write this 1, 2, 3, 0, 4, 5, 0, 0, 6, like this. This is what is upper triangular matrix. Upper triangular matrix. So what is this upper triangular matrix means what? All the elements, same thing. All the elements below principal diagonal are zeros. See here, what is the important thing is, here we said lower triangular matrix, all the elements above principal diagonal are zeros. Then what about principal diagonal and other elements? Okay, only we talked about all the elements above principal diagonal are zeros. Above principal diagonal are zeros. That means what? Other elements. So here another condition is other elements are any real numbers. Any real number. Any real number means what? Even zeros also. Even zeros also. Understand? Now we go back. And see. So here you see here multiplicative identity matrix. Here principal diagonal. Okay. This is above principal diagonal are zeros and principal 0. So these three are zeros. Simply you can say this is lower triangular matrix. These three also zeros. Therefore, you can say upper triangular matrix. Therefore, your scalar matrix is both lower triangular matrix and upper triangular matrix. Understand? Okay. Hope you are clear. Right? So here, this is what I am saying is this is upper triangular matrix also, because below principal diagonal the elements are zeros. This is lower triangular matrix also. Why this is lower triangular matrix? Because above principal diagonal all the three elements are zeros. So this you can call both upper triangle and also lower triangular matrix. So you can say equality of matrices. You can say two matrices are equal if every element, or simply you can say corresponding elements are equal. So for this, what is the condition? If A equal to matrix A equal to B, if matrix A equal to matrix B, then first order of A equal to order of B. Okay, the next here next corresponding elements are equal. Corresponding elements means what? Only order of A equal to order of B, then corresponding elements are equal. Corresponding elements of A equal to B. Corresponding elements of A equal to corresponding elements of B. Corresponding elements of A and B are equal. Simply you can say that. So that's what is equality of matrices. Right. So now here, like this we write Aij. Like this we write. See, generally M by N. How do you expand this matrix? How do you expand this matrix? You expand this matrix like this. M by N. So you write like this, A11, A12. You should be able to write this A1, this one up to A1. And already we wrote and discussed this. You should be able to write this is important. Okay, so on up to A M1, M2, M3, A M2, so on up to A M. This is M by N matrix. M by N matrix. This you should be able to write.